So what we're going to be looking at here is the difference between the idea of a potential and a potential energy, and we're just going to see where this goes. Okay, so we're going to look at a potential versus a potential energy. I know for me, this was a big sticking point. It's just something I had a lot of trouble with, even going through my undergraduate, and even when I started teaching, I was still making mistakes talking about this, which is, something I don't like admitting, but hey, let's face it, if we're going to get better at anything, we got to admit where we messed up. So there is a difference between the idea of a potential and a potential energy. So let's think about what we really already know from last year when we talked about a lot of mechanics and a lot of objects moving. Let's talk about gravity. Okay, so let's just draw in the ground. I'm drawing it flat because we're zoomed in, even though the Earth is very much a round object. And let's just, I don't know, we're going to draw you in the color orange. You're an orange person. Stick figure, as is best figure. Your eyes are together. There you are. Okay. We knew from last year that if we chose a reference point, and let's just choose the ground as our reference point, therefore we're setting its, everything is based from the ground. We knew from last year that if we moved upward above that reference point, we were gaining potential energy. Potential energy being the energy of a position. Okay? So this is how we gained a potential energy. And specifically, this is a gravitational potential energy. Some people write the rate as PEG. We often, in the world of physics, write potential energy with the letter U. So I could call this UG. Ugh. And we know, like, if we had an object up here, some sort of ball or something like that, as we lifted it up, it would gain a potential energy. And what I'm specifically saying here is that the ball or stone or rock or bottle or baby lion that you're lifting above the savannah gained that energy. The object gained the energy. Okay? So imagine that, I've got some sort of magic pen device and I can draw above your head. There is a space above your head. It's right here. An object can be placed there. I could take this ball from over here and I could put it right there, right above your head. If I did that, if I put that ball right above your head, it would have some potential energy. If I let it go, that potential energy would decrease as the ball would fall down in the gravitational field. It would speed up, so losing potential energy, gaining kinetic energy. And then it would strike your head, and you'd be like, ow, why'd you drop a ball on me? But I didn't drop a ball on you. There was nothing there. But there was the potential for me to put something there. I could. There's a space above your head. There could be a ball there right now. But for our scenario, there's not. There's just the potential for something to be there. The idea of a potential is just something could exist in a field. So a potential the potential is given by the field. And for our case, we're here on Earth, the potential that is existing above your head is given to you by the gravitational field. So we often call that a gravitational potential. If you were to take an object and put it up there, the object in the field, which is in the potential, gains that energy or has that energy associated with that position, associated with some reference point. Okay? So another way you can kind of think about this is, imagine you just take like a ping pong ball or a tiny little pebble and you put it above your head. It's just this like tiny, eeny, weeny little object. Well, we know last year that potential energy for gravitation, we can write that pretty easily, if we don't care about a more robust or a very far solution to it, as just mgh, where g is the gravitational acceleration and h is some distance or some height, as you'd like to call it, above the reference point or below the reference point. And this mass is just the object itself. It's just some property. Well, the potential then is just given by GH. Because if I eliminate the mass, that GH still exists. There's still gravity here on Earth. There's still some height above your head. It's when I put that mass in, we get the energy. So if I put a little ping pong ball there, a little tiny pebble, that mass is very little, so the potential energy is very small. But if I put in above your head a bowling ball at the same exact location, G is the same, H is the same, that potential still exists there, but now I've placed into it a more massive object. And that object contains, or it has with it, more potential energy. So the potential is there, and when I place an object into it, it gains a potential energy. This exact same idea can be applied to electric fields and electric potentials. So and the easiest way to think about this is for parallel plates, which we so often use, we'll call this side the positive side, and we'll call this side the negative, the high potential, and the low potential. Remember, whenever we talk about electric fields go from positive to negative charges, so we can think about going from high to low. Remember, for a parallel plate system, these fields are uniform all throughout the inside, except when we get to the edges, we experience edge effects there. We got to be careful about that. But if we're looking at something like this and we want to say, hey, what is this idea of a potential? Well, I currently just have parallel plates with a high and a low side on them. So there is some potential there. This is at some high voltage. We can say the voltage here is, 20 volts. And we can say the voltage on the low side is equal to negative 10 volts. Remember, it doesn't really matter what those numbers are. What really matters is the difference between them, which in this case is 30. So I could pick my high side to be 30 and my low to be 0, or my high to be 90 and my low to be 60. It doesn't matter as long as that difference is 30. With this, though, we have a potential. We have, okay, there is a difference in voltage here. An electric field is formed. That electric field is very similar to the idea of a gravitational field. So we can think about it as, hey, look, if I have this electric field, the idea of the gravitational field, and I move through some distance through it, or I set up some distance through it, such as this distance here, I could call this r, some separation, then that right there, that electric field by a distance, well, that goes very much back to this idea of GH, where G is a field. We can think of it as an electric field this time, and this H we can think of as R, some distance. So that right there sets up this idea of a potential. Now, it's not until I put in a small particle, whether it be positive or negative, but when I put in that particle, let's just call it a small test charge. Well, we know small test charges are positive, and that small test charge being positive is going to move along the electric field lines. As it's moving along the electric field lines, it's being pushed by this positive side, pulled by this low negative side, and it's speeding up. Which means that when I put the particle in that position, when I put that particle right here, right in that field, that particle had some stored electrical potential energy. It had a potential energy because it was in a potential, and it's the object, so there's a potential energy there. And since it's due to electrics, we call it an electrical potential energy. When the object's not there, when I get rid of that tiny little test charge, then there's just an electric potential, or there's just a potential there, or an electric potential, or a voltage, because that's the setup. It's not till we put in the particle that we get an electrical potential energy out of it. And that's a really weird thing that that pops up. So in general, we can think that a potential is given by the field, a potential energy, it's really given because an object exists in the field and can be influenced by the field. So this is really an object in the field. And that field generated the potential, so when that all happens, that's what we see there. So that's the difference between a potential and a potential energy. I hope that kind of gives you an idea of that, especially for both gravitational and electrics. And with that, that kind of dialogue there is finished.